Pythagoras' theorem is a concept that comes in the Year 9 curriculum, and it is all to do with measurement and right-angled triangles. So Pythagoras was a Greek philosopher, and basically what he found was that the square of the hypotenuse, so the hypotenuse is the longest side of a right-angled triangle, so the square of the hypotenuse is equal to the sum of the squares of the shorter two sides. And basically, in simpler terms, that is c squared is equal to a squared plus b squared. And we can use this formula to help us find any side of a right-angled triangle as long as we know the other two. So I've done up a couple of examples for you. The first one is finding the hypotenuse. So what we would do first, and what I usually get students to do, is we just label the sides. So it doesn't matter which side is A and B in terms of the 4 and the 3 here. We know that this one has to be C because it's the longest side. And then it doesn't matter which one's A and which one's B for the other two. So we start by writing our formula. And then after we've written our formula, we can substitute what we know in. So we still don't know c squared, but we actually change it to x because that's what we've been asked to find. A is 4, so we've got 4 squared plus 3 squared. And then we figure out what that is. So 4 squared is 16 and 3 squared is 9, so 16 plus 9 is 25. Now, if you have a look at this triangle, there's no possible way that the distance from this point here to this point here is 25 metres, given that one side is 4 metres and one side is 3 metres. You'll notice that we've still got a squared here. To get rid of a squared, we have to actually do the square root of the other side. So the square root of 25, we figure out what times itself gives us 25, and we know that that is 5 metres. So the length of that side there, if we were to draw this triangle accurately, we would have one side is 4 metres, one side is 3 metres, and then 5 metres on the hypotenuse. And it would make sure that we get a right angle in this corner here. The second example that I've done is finding the shorter side. So again, we just label our sides as C, B and A. So C is always the longest side, which is opposite the 90-degree angle. So we've got C here, and then again, it doesn't really matter which one's A and which one's B for these. Now, if we have a look at this formula, it was C squared equals A squared plus B squared. Now, if we need to find B, because that's what we're trying to find in this example, we need B squared by itself. And if that's the case, we are going to move the A squared to the other side. It's currently an add, so when we move it, it will be a take. So our formula that we're actually going to use now is B squared equals C squared take A squared. And then we substitute in what we know. X squared is equal to 13 squared take away 5 squared. 13 squared is 169 and 5 squared is 25. So 169 take 25 is 144. And then the same thing, there's no possible way that from this point here to this point here that's 144 centimetres given our triangle. So we have to do the square root. So the square root of 144 gives us 12 centimetres. Now the good thing is with this sort of question, if we have a look at both of these examples, the hypotenuse has come out as the longest side. So it means that if you are finding the shorter side and you haven't realised and you do addition by accident, you should realise after you get your answer that you've ended up with an answer that is bigger than the hypotenuse, which is impossible. So you would need to go back and check over that again. So when you're finding a shorter side, so one of the sides that makes the 90-degree angle, it has to be less than the hypotenuse. Your answer must be less than the hypotenuse. The third example that I've done for you is a worded problem. So whenever we have a worded problem, the first step is always draw a diagram if there's not one given. So it says, a 2.4 metre long ladder leans against the wall. It reaches 1.95 metres up the wall how far is the foot of the ladder from the wall? So we need to draw our diagram. First thing, we've got a wall. The wall we assume here is at 90 degrees to the floor. And we've got a ladder leaning against it. Now, when we draw diagrams, we don't need to actually physically draw a ladder or a wall or anything. We just draw a triangle that represents the situation. So we can put in our 90 degrees. Our ladder is 2.4 metres, so we can put that information in. And it says it reaches 1.95 metres up the wall. So we have 1.95 metres up the wall. How far is the foot of the ladder from the wall? So we're going to put our unknown on the bottom there. Let me just rewrite that. And again, it doesn't have to be X. We can use any letter here. So after we've got the diagram, we can then work out what we're doing. Now, if we have a look, the hypotenuse already has a number on it, which means we're going to do subtraction for this one. So we'll have x squared is equal to 2.4 squared, take away 1.95 squared. Again, has to be the biggest side, take the shorter side, because if you do it the other way around, you'll get a negative number, and then your calculator will bring up an error because you can't find the square root of a negative number in our real number system. So we do that on our calculators, and we end up with 1.9575. But we need to remember that it's squared at the moment, so we have to actually do the square root of that answer. And that gives us 1.4 metres to 1 decimal place. Now, I've run out of room here, but in a normal worded problem, you would have to answer with a sentence, and it doesn't need to be a paragraph or anything. It just needs to be the foot of the ladder would be 1.4 metres away from the wall, and then your problem is finished. So just a recap, we've got Pythagoras' theorem. It is only in right-angled triangles. We have the hypotenuse, which is the longest side of the triangle, and then we've got the two shorter sides. If we're trying to find the hypotenuse, we use the addition formula that's here on this page. If we're trying to find a shorter side, we have to use this formula here, which is subtraction, and again we subtract the smaller number from the bigger number to be able to get a positive answer. And again, if you do the question and you know that you're finding a shorter side and you end up with something bigger than the hypotenuse, you need to check, because you've probably accidentally done addition when you should have done subtraction. It's the same with if you're doing this one and you accidentally do subtraction instead of addition. If you don't get an answer that is bigger than the other two, then you've done something wrong and you need to check your answer. Then just with the worded problems, you've noticed I've underlined the important things in the question. I've drawn myself a diagram. Again, the diagram only has to be a triangle. It doesn't need to be fancy. So we draw the triangle, we write out our working, and then I haven't done it on here, but you need to remember to write a sentence answer to finish off a worded problem.